Hey guys, so today in class we are looking at using some Venn diagrams to help us figure out probabilities of disjoint and overlapping events. And so what a problem like this would look like would be something, what is the probability that you draw a 10 or a face card out of a standard 52 card deck? So really what I'm trying to find out is if I want the probability of a card being a 10 or a card being a face card. And today in class when we were using Venn diagrams, we would take these two situations and we would make a Venn diagram out of it. So there's going to be cards that are 10s in a deck, and some of the cards are going to be face cards. So you use those two categories from the problem to make your Venn diagram. And now let's see, in a deck of cards, I get a 10 of spades. So I'm going to say 10S. I get a 10 of clubs. 10 of hearts, and a 10 of diamonds. And let's see, face cards, I have King of Hearts, the Queen of Hearts, Jack of Hearts. I also have King of Spades, Queen of Spades, Jack of Spades. And then the diamonds, King of Diamonds, Queen of Diamonds, Jack of Diamonds. And the clubs, King of Clubs, Queen of Clubs. Let's see, Jack of Clubs. And I don't have anything in here in the overlap because there really aren't any cards that are both a 10 and a face card. If there was, I would have some cards here in the middle. So what is the probability that you draw a 10 or a face card out of the standard deck? Well, there's nothing in the middle there. And so I know that the number of cards that fit this criteria is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total. So if you drew your Venn diagram, you could just say 16. Or you could say 4 of the cards are 10s, 12 of the cards are face cards, and so that gives me 16. And it's out of 52 cards because they told us in the problem it's a 52 card standard deck. So this 16 over 52 I should reduce if I can. So I think, well, I know I can divide it in half. So half of 16 is 8, half of 52 is 26. And let's see, those are even, so I can divide those in half again. So I get the probability of a 10 or a face card. Let's see, half of 8 is 4, and half of 26 is 13, is 4 out of 13. So I have a 4 out of 13 chance of getting a 10 or getting a face card. And you ask, why do you care about this? Well, lots of times in card games, you're waiting for a specific card so that you can make a specific play. For instance, you might be waiting for a 10 or a face card to make a straight, or you might be waiting for one of these cards to make a pair of some sort. So this could be helpful if you're playing a game like that. You could see sort of what your odds are and then use that probability to help you make a bet. Now another type of example where we can do the same thing, it doesn't look as straightforward. So we get out of 200 students in the senior class, 113 students are either varsity athletes or on the honor roll. So varsity athlete is going to be one of my categories, or on the honor roll. And I'm using that or to help me sort of figure out what my two categories are. There are 74 seniors who are varsity athletes and 15 seniors who are on the honor roll. Okay, so let's start putting that information into a category, right? So I've got two circles. They may or may not overlap, but I'll put an overlap there. There just might not be anything in the overlap. So I've got varsity athlete, and I've got honor roll. Okay. And I know I have 200 students total. I'm going to pull out the important pieces of information out here. Totals, total. 130 students are one or the other or both. So I know I have 113 total in my Venn diagram. 74 seniors are varsity athletes. So that means I have 74 kids who are varsity athletes. 51 who are on the honor roll. Let's see, 113 who are both. And now if I take 74 and I add 51, let's see, 4 plus 1 is 5, and 7 plus 5 is 12. So I get 125 students here. Well, what that tells me is that there are some students in this overlap because I've double counted. Like, I know that there's only 113 students who are both And so I want to figure out what this overlap is. And to do that, I'm going to take the difference between the number I'm getting total and the number that they already told me are one or the other or both. So I'm going to take 125, take away 113, and let's see, 5 minus 3 is 2, 2 minus 1 is 1, and that cancels out. So this 12 has to be the number that are in both. Now I've got to adjust these down for us to like make this work, because right now if I have 12 that are both and 74 in the same circle, then I would have to add 74 and 12, and that would give me 86 varsity athletes, but I know I only have 74. So I have to do 74 minus 12 to get 62. So 62 of my athletes are only varsity athletes, of my seniors, and 51 minus 12 gives me, let's see, I've got to borrow here, 39. So that means that 62 are only varsity athletes. They're not also on the honor roll. 12 of the students are both varsity athletes and on the honor roll. So those are your 12 varsity athletes that are Smarties. And then we've got 39 students who are only honor roll. And now let's double check, because that should add up to 113. That should be the number that are in one or the other or both categories. So 2 plus 2 is 4, plus 9, yep, is 13, and I bet up. And then 1 plus 6 is 7, plus 1 more is 8, plus 3 more is 11. And so sure enough, that checks. That gives me the 113 that I know are one or the other or both. Okay. So Venn diagrams sometimes can help you sort of sort this out also. Remember that if it's in the middle of the two circles, it counts for the varsity and it counts for the honor. So you have to, if you know what that number is, it can't be counted in just the varsity or just the honor roll. All right, that's it for notes tonight, guys. Thanks.